Hello student, and welcome to the last lecture video of Advanced Graph Theory. In the last video we are discussing what is the meaning of prefix code and what is the purpose of doing this prefix code. In this particular video I am going to discuss how to represent a prefix code in a binary tree. So let's start with that particular thing with an example. Now if we consider this particular example 0 1 1 1 1 0 1 0 110 and 100, you can easily find out this is a prefix code because there is no element in this binary sequence which is a prefix to another element, right? So how we can represent it? Let's check it. 0, as per definition of our prefix code, 0 should become in a left side, so 0 should be there, so this is 0. If we can consider this is a vertex and this is a vertex, right? Now how you can draw this 1 1 1? It can be 1, it can be 1. I am considering this is a vertex, right? This is another 1. So this is 1, 1 and 1, right? So how about 1 0 1 1 1? So this is 1 is already there. So how we can get? We can get 0 is there. Now what about this one? 1 1. So it should be 1 and it should be another 1. So this is another one, this is another one, right? Now what about 1 0 1 0? 1 0 is there. So we need 1 0 1. So another 0 should be there, right? This is 1 0 1 0. Now how about 1 1 0? 1 1 0 means 1 1 is there. So this should be the 0, that is 1 1 0. Okay. Now the last one 1 0 0. 1 is there, 0 is there. So we should understood to write 0 here. So I am actually writing it, or I am draw it in a very proper fashion here for your betterment to understood this one. Now the interesting thing is come that how we can we are already representing it, but how we are symbolically represent these things in this prefix code. Just check this one. One thing should be remember in your mind that every leaf element, every leaf node is actually a symbol, a character. Here I am represented is an A, exclamation sign, D, C, R and B. So you can find out the value of A is basically encoded as 0. The value of exclamation sign is basically encoded as, that is 100. The value of D is basically encoded as 1010. The C is encoded as 1011 and so on so forth. You can find out there, right? So this is the representation of a prefix code in case in the binary tree, right? So this is most important for you people. You should understood. I hope you understood these things. আমার যেটা মনে হয় তোদের যেটা করা উচিত যে you people should taking another more example, another more prefix code and do it yourself so you can understood it very easily, right? Now what is the strategy? You people are already understood the strategy. Actually, if a leaf in a tree represent a symbol, any of its ancestors cannot represent any other symbol. তার মানে কি? তার মানে যদি কোনো একটা leaf node কোনো একটা symbol কে denote করে তার কোনো ancestor, these are the ancestor or the parents, so they cannot represent any symbol, right? So this is the purpose for this encoding or the strategy for this encoding, because this is the last thing what we have discussed in the property or in case of purpose of prefix code, right? যেখানে leaf node এর symbol কোনোভাবেই তার ancestor এর কারো সিম্বলের সঙ্গে ইকুয়াল হবে না. Now the last thing is that bi-connected components and articulation point. Now what is the meaning of bi-connected components? That means a graph capital G V comma E is said to be bi-connected if it has no single vertex such that its removal increase the number of connected components in the graph. I'm just giving you a very simple example. I will give you another example on a later stage. Suppose this one. Just consider this one. Suppose this one is there and there is another. This one is there. This is 1, number 1 vertex. This is 2. This is 3, 4, 5. It may be 6 and it may be 7, right? So if I'm asking you to remove this 4, what happened? This particular component in this particular graph is connected graph, right? I'm not considering the tree, the graph. So this total graph is connected graph. So if we can remove this 4, what happened? It is distributed or it is divided into 2 components, 2 connected components, because this one is one component, this 1 2 3 and 6 7 5 6 7 is another component, right? Now, what is the definition of articulation point? So I'm just told you that if there exists such a vertex, then it is not biconnected, definitely. Now, a vertex whose removal increases the number of connected components, it calls the articulation point. That means for this particular example, 4 is an articulation point. For this example, this is a biconnected graph. You can check this one, because if you can remove any vertex, this cannot be disconnected. It is always being connected, right? But just consider like this way, that I am putting one vertex there, and like that. Okay, so if I remove this particular vertex, this is the articulation point, and it changes or it divides into 2 components, right? So I think it is understandable for everyone that what is the meaning of biconnected components and what is the meaning of articulation point. So that's all for this advanced graph theory. Now on the next day we will start discussing the basic things of the discrete mathematics, that is the permutation combination, the pigeonhole principle, and all that things. Thank you.